Welcome back to some more geometry. We're starting our new chapter today, chapter 6. This chapter is over quadrilaterals. Now, this angle of polygons is kind of like they needed to talk about this certain thing, so they just stuck it with quadrilateral. But the chapter is mostly about four-sided figures, but we're going to talk about angles of polygons in general for any kind of polygon. All right, so now diagonals, talk about diagonals real quick, are a segment that joins two non-consecutive angles, two non-consecutive sides. So for example, if I do a consecutive, it'd just be a side, but I do non-consecutive, you get one diagonal. Now, as shapes add more sides to it, as we start getting more sides in our polygon, we can get more diagonals. But in all of these right here, every single one of them, how many triangles are there? In a square or a quadrilateral, there's 2. Pentagon, 3. Hexagon. This is a 1, 2, 3, 4, 5, 6, 7, 8 octagon. 1, 2, 3, 4, 5, 6. As you add one more side, you're able to get another triangle out of them. Now, this is important. This is kind of the mindset behind this. Everything can be broken down into how many triangles are in this whole thing. So, as we talked in the last chapter about triangles, we know that the sum of the interior angles of a triangle is 180. Well, what's it in a quadrilateral? Yeah, it's 360. Think about it. 2 180s. So then a pentagon will be 3 180s, and so on and so forth. So some very, very smart person a long time ago discovered that, hey, we can just think of any polygon. So let's find the sum of the measures of the angles of a convex. And it's very important we say convex, meaning everything faces out. Because if you have a pentagon that looks like this, it ruins the, there you go. Like this, angles change, things change, rules change. So I'm talking about convex. The sum of the measure of all the interior angles, and by the interior angles, we're talking about the angles at the corners. At every corner on these, regardless of this, it can be found by taking this formula, n minus 2 times 180, where n right here represents the number of sides. So let's kind of try that out. Let's see if that's true. So like we said, this should be 360. So the way this will work would be number of sides, 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180 gives us, 360. Good. All right, so let's do with the pentagon. And what I want you guys to do is, if you want to, go ahead and pause and try these all out right here, and then I will go ahead and continue and then do them all. So here we'll have 5 minus 2 times 180 gives us 3 times 180. Like we said, there's 3 180s. Oops. 3 times 180 is 540. Okay. So then 4. Number of sides will be 1, 2, 3, 4, 5, 6. 6 sides. So it'll be 6 minus 2 times 180. You're getting 4 times 180. 4 times 180. Get a grand total of 720. And that octagon, 8 minus 2 times 180. You end up getting 6 times 180. So 6 times 180, get 1080. These are the sum, so the total of all the angles added up. Now the reason we kind of focus on sum sometimes is because, we don't, this is for any polygon, whether it's regular or not. So on a regular one, they're all equal to each other right here. They're all equal to each other. But on a non-regular one, they're not equal to each other, so we still get the same total though in all of them regardless. So as we've gone through this, these triangles are classified by certain names. So as we said, a 3-sided figure is a triangle. 4-sided figure is quadrilateral. We want to call it a rectangle or square. And those are specific kind of quadrilaterals. But quadrilateral is just a name for any 4-sided polygon. Pentagon, hexagon, heptagon, also known as septagon. So heptagon, I think, is the Greek name. I think septagon is a Roman name, or vice versa. Again, 8-sided figure is octagon. 9-sided figure, my favorite one, is a non-nagon. 10 is a decagon, Anybody remember what was a 1,000-sided figure? A kilogon. Kilogon. A million-sided figure is a megagon. Megagon. A 100 to the 10th, no, a 10 to the 1, 10 to the 100th power, so a 10 with 100 zeros is a googlagon. But any sided figure past pretty much 12, I think 12 is a dodecagon. Anything past that, you just call it by the number of sides. So a 15-sided figure will be called a 15gon. Just because this is more, there is an actual name, but we don't, I guess, just don't focus on those actual names past a certain number. So for example here, let's go ahead and find the measure of each interior angle. So each angle right here. So we already have one. We know what A is. So we're looking for A, B, C, D, and E. Okay. So we have A, it's 142. Okay. Now first, let's think about it. What's the sum right here? Let's find the total sum. So it'll be, it's a 5-sided figure, so 5 minus 2 times 180. So that's 3 times 180. What we said was it was 540. So we know the whole thing, all 5 of these add up to be 540. So we can write this as one big old thing. So we say 140, or 142, sorry, 142 plus 2x plus 2x plus 3x plus 14 plus 3x plus 14, all equal 540. And this is all 5 angles being added together. So that's 1, 2, 3, 4, 5 angles. So the 5 angles. So it's combined like terms. So 2x and 2x is 4, 3x and 3x. So that's 7, 8, 9, 10. 10x. So 10x. Add our numbers. We got 140. 140 plus the 14 plus the 14. So plus 14 plus 14. That gives us 170. That all equals 540. So the rest is just solve for x. So let's solve for x. So we'll subtract 170 from both sides. So minus 170 minus 170. You get 10x equals minus 170, 370, and then divide by 10. The value of x equals, 37. Good. So now all we got to do is just substitute that back in. So then 2 times 37, 72. So that'd be the same for B and E. So B would be 72. Oh, 74. Sorry. 74. E would be 74. And then 3x would be 3 times 37 plus 14. So 3 times 37 plus 14 gives us 125. 125 right there and 125 right here. All right, y'all. And that's how you do it. Now, the reason, again, like we said, this is always true, regardless. This is not a regular polygon right here, or not a regular pentagon. You know, these sides, it's a little bit more squished. The angle is a little bit different. But what's still true is that all 5 angles added up is still the same, regardless if it's a regular pentagon or not. Now, before we move on, fun fact real quick, the sum of all exterior angles of a convex polygon, regardless of what it is always 360. Had to put this in somewhere. That's why I put it right here at the very bottom. So it doesn't matter how many sides it has. If I add up all the exterior angles, and the exterior angles happen when we extend the side. So if we extend this side, this side, this side, and this side, you have 1, 2, 3, 4 exterior angles. If you're doing a pentagon, you have 1, 2, 3, 4, 5. 5. So for every number of sides that is, there's that many exterior angles. But regardless of what it is, if I add them all up on here, it's 360. If I add them up all right here, it's 360. If I add them up right here, they're all 360. If I add them up here. So it doesn't matter how many. So that being said, another way we kind of look at this is check this out. As we extend this side right here out, these 2 angles together will always make 180. Always. So if you find one, you can subtract that from 180 to find the other one. If you know the exterior, subtract that from 180 to find the interior. But let's go ahead and do this. It says, hey, find the measure of each interior angle and exterior angle of a regular nonagon. It's a regular nonagon, okay? So that means all angles are the same. So let's do the sum first. So the sum would be 9 minus 2, because it's a nonagon, times 180. So 9 minus 2, we get 7 times 180 right here. So we do 7 times 180, you get 1260. Now here's the thing. We don't have nothing on the inside to represent it, but that's fine because they are all equal. And because they are all equal, you can just divide it by the number of angles we have, which is 9. So we take that 1260 divided by 9, and we get 140. So each of these is 140 right here. And I'm gonna also. Now, that being said, as we extend this, remember, all of them is 360. And we'll look at the two different ways. So what we could have done from the very beginning is just take 360, divide that by 9. So we take 360 divided by 9. What do we get, y'all? Yeah, we get 40. So this is 40. Each of these are 40. But also, remember, these two together will always make 180. So 140. So we can take 180 minus the interior angle, and we still get 40. Either one would be correct. So I want you to think of those both ways like that. Hopefully this helps. Homework won't be too bad, y'all. Let me know if you need help. Bye.